How do we know how old a dinosaur was when it died? This is going to sound like a joke, but I swear the actual answer is you cut it open and you count the rings. This is also going to answer this question. Growing bone costs energy, and in most ecosystems, at some times of year there is less energy to go around than at other times of year. Usually that means winter, sometimes it means seasonal drought. Either way, during those times, the animal's growth is going to slow down or stop, even if it's otherwise at a life stage, like youth when it would be growing a lot. When an animal stops growing and then starts growing again, it leaves a line on the bone. These are called lags, which stands for lines of arrested growth. Actually, this is also why trees have tree rings, in case you were wondering. Here's an example taken from this paper of lags in the bone of an adult Tyrannosaurus. In addition to helping us estimate how old the animal was when it died, you can also use lags to tell how quickly the animal was growing at different points in its life. So if the lags are really quite far apart, the animal grew a lot in that year, and if they are closer together, the animal grew less in that year. Here is a cross-section of a bone from Jane, the possible Nanotyrannus specimen, which was used by the authors of the new pro-Nanotyrannus paper to argue that this specimen was approaching adulthood when it died. I also want to use this to illustrate another thing about lags, which is that, as you can see, there are a few places where there are lags that are weirdly close together on this cross-section that don't seem to be consistent with the seasonal pattern. Sometimes lags don't represent a whole year, sometimes weird things happen. There are a lot of things that could mean. Maybe the ecosystem was hit by a random non-seasonal drought that starved all of its inhabitants a little bit, and did not represent a whole year. Maybe at those periods in time this animal was sick or injured and not feeding itself properly. Maybe they do represent years, and the year-to-year growth pattern of this animal was just really weird and inconsistent. It's difficult to prove any of those ideas, and I hope that gives you a little sliver of why it is so difficult to agree on stuff like this, and why different workers can credibly come to different conclusions about what lines of arrested growth actually mean in a specific specimen.